Alright, so today we're going to concentrate on various common factor, but I want to review factoring with you. So let's just remind you what we did on Friday. So 9-1, this is going to be B, which is day 2. And this is factors and greatest common factor. Remember, this is going to be called GCF. The one thing that we did not talk about on Friday was the greatest common factor. So we're going to spend most of our time today looking at that. So let's just review. So if I ask you to list all possible factors of the number classify. TJ?
Yeah.
Get your backpack off your desk and let's get serious.
Sorry, Miss Maria.
There you go. Then classify as prime or composite. And here's your number. So go ahead and do that. Remember, you're supposed to know the difference between factor versus prime factor. So this is asking you to list all factors. So use your divisibility rules. What's the first set of factors for 70? 1 and 70, right? You always start with 1, the number. Does 2 go into 70? Yeah, because the number's even. Does 3 go into 70? What's the rule for 3? Yeah. So what's the sum of these digits? 7. Is 7 divisible by 3 or 9?
No.
So neither 3 or 9 go in there, so you have to remember that for 9. What about 4? You just have to divide 4 in there because it's a 2-digit number. Does 4 go in there evenly? Or is 70 one of your multiples of 4? Yes or no? No. Does 5 go in there? Yes, because it ends in 0. How many times? 14 times. So now we're only looking at the numbers between 5 and 14. Does 6 go in there? No, why not? Because 3 didn't go in there. Both 2 and 3 have to go in there, and they don't both go in there. What about 7? Yeah, so 7 goes in there 10 times. So now all we have to look at are the numbers between 7 and 10, which are 8 and 9. Does 8 go in there? No, why not? Because 4 didn't. And what about 9? We already tested it, right? So we're all done. Is this considered prime or composite? Composite. Alright, so that's mostly what we did on Friday. The other thing we did was prime factor. What if we were to prime factor 70? How would that be different? What do I use to prime factor? Factor trees, right? What's the biggest number that divides into 70 out of your divisibility rules? 10, right? So 7 times 10 is 70. Any one of those two prime? The 7, so circle it. Then 10 breaks down into what and what? 2 and 5, or 5 and 2. And then would you leave your prime factorization looking like that? What comes first?
2.
The smallest is 2, so 2, then 5, and then your 7. So that's really all we did on Friday. Difference between prime factoring versus just factoring. All right, so let's look at prime factoring with variables. The one thing that we did not do was prime factoring with variables. So how does that change it? Example 2. It really doesn't change it much. Give the prime factorization of each number. So we've got two different numbers that we're going to look at. The first one is 18 x cubed y cubed. So what I want you to focus on is the fact that we're looking at 18. Don't worry about the x cubed and the y cubed. The prime factorization of those is really simple. So go ahead and prime factor 18. Use your factor trees. So what's your lowest prime for 18? 2. What's the next lowest? 3. And how many 3's do you have? 2. So this is what your factoring looks like, but you have to physically write it as 2 times 3 squared. So the question is, what do you do with your variables? All you do is tack them on. Times x cubed times y cubed. That's it. So the variables really don't change anything that we did, does it? Nope. So do this one on your own. There's something in here that hopefully you'll remember what to do with. Negative 26 r s t squared. So prime factor that. Remembering, what do you do with that negative? So how does the negative affect your prime factoring? You pull out a negative 1. Where does it end up going? At the very beginning, right? So you should have realized that 2 went in there, and once you divided 2 in there, 13's prime, so you're done. So your prime factoring should be negative 1 times 2 times 13, but then bring down your variables, separate them with multiplication dots. It sounds picky, but if you forget to separate them with multiplication dots, you're going to lose points. So this is proper prime factored form. So any questions on that? All right. So then let's talk about greatest common factor. So I'm going to give you a detailed list of how to find it. There's a lot of different ways that we could use. I tend to use the same exact way for greatest common factor and least common multiple. We just do something slightly different. So write the following down. How to find. This is a foolproof method. How to find GCF. I can spell it. GCF, which is your greatest common factor. So we're going to follow 4 different steps. So step 1, you're going to prime factor each number in the group. Just reviewed how to do that. Number 2, you're going to stretch. So instead of writing it in exponential form, you're going to stretch them out. So if you have 3 2's, 2 to the third, you're going to go 2 times 2 times 2. So you're going to stretch out the primes of each number horizontally. circle all primes the numbers have in common. Every single number has to have the prime in common for you to circle that prime. And then one last step, we will multiply one number from each circled group together to find the GCF. It sounds complicated, but it's not really. So I'm going to do something that's simple with just two numbers. And some of these you're going to be able to do in your head, but then some you won't be able to. So greatest common factor really means what's the biggest number that I can divide every single number in that group by. You'll start to see a pattern forming the more of these that you do, and you'll start to see a shortcut to this method. I won't do this method forever because it takes a lot of paper. But for right now, we're going to do it this way until everybody sees what we're doing. And then we're going to start to see, well, how can we shortcut this? By using factor trees only, and our prime factorization and exponential form only. And so it's one thing that I want you to look tonight is as you're doing this, how can I lessen my work? What's the pattern that I see, and what's a new plan that we can use that works all the time? All right, so what if I had the numbers 2 and 6? What's the biggest number that divides into both 2 and 6? 2. Does everybody agree? What if I had 6 and 21? What's the biggest number that divides into 6 and 21? 3. What if I did instead 66 and 90? Is that harder to do in your head? Yeah. So we're going to take 66 and 90, we're going to follow each of the 4 steps above. So the first step says prime factor each number in the group. So we're going to use our factor trees. What's the biggest number you want me to use for 66? 11 and 6, right? So 11 and 6, 11 of which is prime, and so then 6 is your 2 and 3. So don't write it out yet. All we're going to do is prime factor it, and then prime factor 90. I'm going to use 9 and 10, and then 9 is 3 and 3, and 10 is 2 and 5. So that's step 1. Step 2 says stretch out the primes of each number horizontally while lining up like primes. So we're going to go again from smallest prime to biggest prime. So we're going to start with 66, and I'm going to put a colon, because these are the factors of 66. So I'm going to put 2 in one column by itself. Doesn't this one only have 1, 2? Then I'm going to put a 3 in another column by itself. This one, however, has 2 3s, so I'm going to save a little bit of room here. And I'm going to put the 11 kind of over here somewhere. So these are all being multiplied together. So I've accounted for all 3 of my primes. Then we're going to put the 90 down here. And I've got a 2 for the 90, so I'm going to put that directly under. I'm lining up this like prime in that column. But I have 2 3s. So one of the 3s goes underneath here and lines up with the 3 from 66. And the other 3 makes its own column, because I have nothing to line it up with. And then we have a 5. Well, the 5 doesn't line up with 11, so I'm going to put it off over here to the side. So these all get multiplied together. Then I want you to draw a line underneath all that. So step 3 says circle all the primes numbers have in common. Do they have a 2 in common? Both of them have a 2. Do they have a 3 in common? How many? Well, just one. Technically, they each have 1 3 in common, right? This doesn't count as 2 3s. If I could circle another set of 3s, that would count as 2 3s in common, but they only have 1 3 in common. Do they have any 11s in common or 5s in common? So the only thing they have in common is 1, 2, and 1, 3. So step 4 says, and here's what you're going to do, bring down one number from each of the columns down below. And then multiply them together. So what's 2 times 3? So the GCF is equal to 6. If I divide 66 by 6, what do I have left? 11. If I divide 90 by 6, here's my 6, what do I have left? 3 times 5 is 15. Does 11 or 15 have anything else in common? That's kind of how you can check it. No. So the greatest number that I can divide into each one of them is 6. The other way that you could do this is you could find all the factors of 66 in that horseshoe method and find all the factors of 90 in the horseshoe method. And whichever factor they have in common, that's the biggest, which will end up being 6. You can do it that way. I just find finding factors a lot more work than finding prime factors. So instead of doing these horizontally, again, as we do these today, I want you to figure out, well, how can I shorten that up? How can I figure out a shorter way to do this? Well, not yet. I want people to think. All right, so let's look at something a little bit more complicated. Well, before I do that, I'm going to give you something that you probably won't be able to do in your head. So do this one on your own. Example 3. Follow the steps that we just took. You're going to find the GCF. Of 123 and 220. Use your divisibility rules. Get them down to their prime, so follow those 4 steps. Divisibility rule works for 123. What's the only rule that works? The 3's rule. Always apply that rule first, because it's possible to get 9 that might go in there. Does 9 go into 123? No. Because 1 plus 2 plus 3 is 6. 6 is not divisible by 9. But 3 does go in there. And if you memorized your primes, which you're supposed to be memorizing them, right? By what day? Tomorrow. So starting Thursday, you can have a pop quiz. So learn your primes. So 41 is prime. So this one is just 3 times 41. 220 ends in 0, so use 10. 22 times 10. 22 is 2 and 11, and 10 is 2 and 5. Doesn't that give you 2 squared times 5 times 11? Okay? If I line up their primes, so here's what I did when I lined up their primes. The 220 has 2 2s of 5 and 11. I'm going to try to order them in numerical order. The 123 doesn't line up with the 2s or the 5s or the 11. And the 41 doesn't line up with any of these. Do they have any primes that are in common? At all? No. So technically there is no greatest common factor. I guess actually technically there really is. If you went and you found all the factors of 123 using the horseshoe method and all the factors of 220 using the horseshoe method, what factor would they all have in common, both of those? 1. So technically the greatest common factor is 1. So here's what you're going to say for this one. The GCF is equal to, you can either say relatively prime, and you need to know what the phrase relatively prime means. Relatively prime means that they don't have any primes in common other than 1. or I will allow you to say 1. Either one of those two answers are acceptable, but you do have to understand what relatively prime means. And it means that the two numbers, the only greatest common factor that they have is 1. All right, so let's be a little bit fairer. Do this one on your own, since that one was tricky. This one's not a trick question. For example 4, find the GCF. This time I'm going to give you 3 numbers. So 42, 63, and 105. Most likely you would not be able to find the GCF in your head without a lot of thinking. So prime factor, stretch out their factors, line up what they have in common, circle what they have in common, and multiply together. Factor 42, you get 2 times 3 times 7, and 63 you get 3 squared times 7, and 105 you should get 3 times 5 times 7. So if I stretch them out, I do a little pre-planning. None of them have any 2's in common. So for the 42, it gets its own column. Then this one has 1, 3, and that has 2 and that has 1. So I have to make 2 columns of 3's. So here's one column. And I'm going to skip because I know I'm going to need a second column. And then I've got 7. So here I would line up one of the 3's. The other 3 would go in its own column. And then the 7 lines up. And then 105, the 3 lines up. The 5 needs to make its own column over here. But the 7 lines up. So what do they all have in common? Which primes? They all have a 3 in common, and they all have 1 7 in common. They don't have 3 3's and 3 7's. They have 1 3. So your GCF is equal to 1 3 times 1 7, which is 21. Now you want to make sure that what you chose, 21, actually divides into both of those. You didn't make a mistake. 21, here's your 3 and your 7. Wouldn't you be left with a 2 on this one? And 21, you've got a 3 and a 7 here, you'd be left with a 3 here. And 21, here's the 3 and the 7, you'd be left with a 5. So what you're left with, they don't all have anything in common. Now, what if there had been a 3 in this column, just right here, but no 3 here? Would you be able to circle the 3's? The second set of 3's? No, because they all 3 have to have it in common. You can't just have 2 of them have it in common, but all 3 have to have it. So the GCF for this one's 21. So again, you're looking for a shortcut, right? All right, what happens if we have variables? So let's throw variables into the mix. Example 5. Find the GCF. And here's where you might start to see the shortcut. We've got 27 a squared b, and then 15 a squared, I'm sorry, not a squared, a b squared c. So if you prime factor 27, 3 times 9, and then 9 is 3 and 3. So we've got 3 to the third times a squared times b. And then 15 is 3 times 5, which gives us 3 times 5 times a times b squared times c. So we're going to line them up. What happens with your variables is they start to get really long when you line them up, and this is why you're looking for a shortcut. Are you writing along with me? Because it looks like you're not again. So 27a squared b. I've got 3 3's. And I've got to save space for a 5, so I'm going to save a space here. And then I've got a, 2 a's, and a b. Then for the 15, a b squared c, I've got a 3 and a 5, so I'm going to put the 3 on this last column. Nothing says I have to have it in the first column. You can put it whatever column you want to, just line it up with one of them. 5 has its own column. This a lines up with one of these a's. This b lines up with one of these, and then we have another column for the second b. And then the c needs a column. So find a GCF. What do they have in common? A 3. What else? 1a. What else? And 1b. So if I multiply all that together, don't I get 3ab? Okay. So what I want you to start to do is start to look at this prime factoring right here and this prime factoring right there, and kind of determine how can I go from these two to 3 times a times b. How can I look for that shortcut? There's a pattern that always follows, so start looking for it. Last example. This time I'm going to give you 3 of them. I want you to try it on your own and see how you do. So example 6, and they're going to have variables. Find the GCF. Remember, these can also be relatively prime. So we've got 15 r squared s, 35 r s squared, and 70 rs. So prime factor. What do you guys need? You're just saying hi. Hello, how are you? They're freshmen. 5 girls. So we have 3 and 5, which is 3 times 5 times r squared times s. DJ? DJ. TJ?
Sorry.
5 and 7, which is generally why I close my door. And then 70 is your longest factoring. So we have 2 times 5 times 7 times r times s. So we only have factors of 2's, 5's, and 7's between the 3 numbers. So line them up. So I've got a column for the 3, a column for the 5, and then I've got 2 r's, and then an s. And then for the 35 is a 5, so I'm going to line it up here, and a 7, it needs its own column. 1 r, but 2 s's, so another s for its own column. And then the 70 has a 2, so I'm going to put the 2 at the front. You put it back, it's fine. Line up the 5, line up the 7, line up an r, and line up an s. Remember, for there to be a GCF, all 3 have to have it in common. So is 7 a common factor? Is 7 common? Nope, because this one's missing it. So what do they have in common? All three. What's the first one? They all have a 5 in common, right? So bring down 1 5. They all have what else? An R. So bring down an R, and what else? An S. So your GCF is 5RS. But it's easy, right, so far, but time consuming, isn't it? Do you want to stretch them out like this forever? I want you looking for a shortcut, and I want you to tell me what it is tomorrow. Because starting tomorrow, I'm going to do the shortcut. Unless you like the long method, that's fine. You can do it the long way each and every time, but we could end up with something stretching all the way across the paper and running out of paper. And that would be a pain. So do look for the shortcut.